This video is intended to help you deal with questions regarding confidence intervals for proportions. In this first question, it says that a State Department of Education reports that 12% of high school students in that state attend private high schools. And the state university wonders if that proportion is the same for their application file, or for all students that their applications are on file. And so that over 10,000 is our population for the state university. And what the question asks for is how many applications should they sample if they want to be within 4% at 90% confidence. And so we start this by defining what margin of error is. Margin of error, right, is a length. And if we look at a confidence interval in terms of visually, it is the length of these stems, right? That's your margin of error. And the formula for margin of error formally is defined as a critical value, z star, times your standard error of p hat. The margin of error in this case is 0.04. That's the margin of error that they desire. With 90% confidence leaves us a z star of 1.645 times the square root, right? Standard error of p hat is defined as the square root of p hat q hat over n. And we don't yet have a p hat, so we'll use the given 12% as a reasonable estimate at this point. We have no reason to believe otherwise, and it's probably pretty close, so we'll use that. In cases, and that's going to be over n, in cases where we don't have any information, we would use a p hat of 0.5, which would be sort of erring on the side of caution. Now the rest of this is just some basic algebra. So we're going to divide both sides by 1.645 to get rid of that. And that leaves us with a value of 0.0243. And we're going to square that value to get rid of the square root. And that leaves us with 0.12 times 0.8 on the top over here. It's going to be 0.10556 all over n. These two values, well, after we go through a series of cross multiplication and realize that actually they can switch positions algebraically, so n is going to be equal to 0.1056 divided by 0.0243 squared. And if that algebra eludes you, just see me during class and I'll explain that more. And you get a value of 178.83, and so you can't have that many records. You got to pull in a whole number of records. So n is going to be equal to 179 records. So that answers the how many applications, I should say, should they sample? They should sample 179 if they want to have their confidence interval be within 4% of the true value with 90% confidence. Now the next question says, well, they actually selected 450 applications. So that's n. And 46 of those, right, that's the number of successes, are students that attended private schools. So our p hat is going to be 46 over 450. This gives us a value of 0.102, or about 10.2%. And then 1 minus p hat is going to be 0.898, and we're going to need that value. So our confidence interval has to be preceded by a series of checks and balances. One is going to be that this sample is random, thus preserving the independence of each student. So let's assume that we have a simple random sample. Next, we need to have observed at least 10 successes and 10 failures. We saw 46 successes, so that's greater than 10. And then 450 minus 46 is 404, which is greater than 10. So we have 10 successes and 10 failures. Couldn't be any more sloppy, and that word is failures. Okay, and then 450 has to be less than 10% of our population of applications. And so the population of applications was over 10,000. So if you just said it was 10,000, 10% of 10,000 would be 1,000. 450 is definitely less than 1,000. So what we'll say is it's okay to use a 1 proportion z interval. Okay, and then our z interval is going to be p hat plus or minus z star times our standard error, which is 0.102 plus or minus 1.645 times the square root of 0.102 times 0.898 all over, 450, not n. Sorry about that. A little sloppy here. And after full calculations, and you take this all out, you should get 0.079 to 0.126. Moving on to interpret this interval, we're going to say what we have right here. You might want to pause it and write it. That we are 90% confident that the true proportion of applicants who attend private schools is between 7.9 and 12.6%. Now, what does the 90% confidence mean in this context? That simply just means that if we were to repeat this over and over again, and we had multiple intervals, 90% of those intervals would capture P, the true proportion. Not all of them. Now the question is, well, which one is this? I believe that this confidence interval actually captured the truth. And how much of assurance do I have? About 90% certain. The biggest question of all is the whole reason why we did this was this question right here. Should the administration's officers conclude that the percentage of private school students in their applicant pool is lower than the statewide enrollment rate of 12%? Well, the numbers go from 7.9 to 12.6. So should they conclude that it is lower? No, because 12% is in our interval. If I believe that the true P is somewhere between 7.9 and 12.6%, then it's plausible that the enrollment rate from private school students or applicant rate is 12% as well, because it is somewhere in the interval that I believe holds the true value of P for our population, which is the over 10,000 applications. Hopefully, this helps. Now let's use the calculator to help us out. We're going to go ahead and hit the Stat button, and when we hit the Stat button, that brings us to this screen. We scroll over to the word test, and we're going to arrow down. Down till we get to this letter A. You can either scroll down and hit enter once you get to A, which is a 1 proportion z interval, right? The rest of this is interval. Or you can hit alpha, and then the button below it is math. That would be alpha A, would bring you right to alpha A, which brings you to this screen, 1 proportion z interval. And all we have to enter in here is our x value, which was 46, sample size is 450, confidence level as a decimal, 0.9, calculate, which brings us right to here, and as we notice, 0.0787, which is 0.079, and 0.1257, which is 0.126, as we had in our calculations, and then of course our p hat value of 0.102 repeated, which is 0.102, and then you're all set. I would use this as a check to doing this by hand. The by hand calculation is nice because you still get that practice of dealing with the margin of error and having an understanding of what's going on. And some questions will want to ask specifics about pieces of the journey and not just the interval itself. But this is a great way to check to see if you have the correct interval. There's lots of places to make little arithmetic errors. All right, and that's it for confidence intervals for proportions.